Hey all, in this stream, we are going to write Git from scratch. It may be a bit huge of a task, but I guess we're going to write a few features, some important ones, and on the way, we're going to learn some things. Even I'm going to learn some things because I have not written Git before. Um, but before that, I think we need an understanding of how it works. Just remove this infinite thing. We just need an understanding of how it works. So we'll be just going through the internal working once, and then we are going to write it in Zig language. Why Zig? I think it's probably because it's low level. It's much more low level than Go. You could do it in Go, but I think with Zig, I think it's much. I don't know. I like Zig nowadays, so I'm just trying that out. Not just that, it's because of the level of uh, closeness you have with the hardware, right? So that's probably where Zig shines. So yeah, let's get started. So I just want to see what can we implement. This might be probably a bit longer stream because I don't have understanding of Git that a deeper understanding of the Git that I need to write it on my own. So before even writing, I need to understand probably a few things so that we can start writing that. And even that, I think we have probably uh, we need more context on how Git works. So that's what we are going to work on the first phase. So there are multiple things in Git. So from the top level, I think we have trees. So trees are the first thing that we have in Git. Everything is a tree, or you could say there's a blob. Blob is binary large object. So whatever the file content is there, it's a blob. Everything is a blob. Every file content is a blob, not, and these don't have names. They are just the name of the blob is just a hash of the blob. What I mean by that, I'll just come back to that in a minute. And we have a commit. We need to see what are the types of objects. We have a cheat sheet. I need to see what what are the entities that we have. So I'm just putting out the entities here. I don't know if we need it. We're going to implement that, but there's a branch. So there is trees, commit, branch. What else? There's a log. Um, so where do we even see that? Edit objects. So we can take an example repo and then see. Let's go to where do we go? Let's go to my profile once and see what we have something. So I guess we can just pick any one of the repo we have. If I go back here, let's go to dev and have this 8-bit CPU return previously in Zig as well. So if I do the dot files, we can see the dot git. So the hidden files, and we have this objects, which is what the hashes mean. But we can't read this if we view the file. So git has a cat file. This is what it is. This is the hash of any object you take, and it's a commit. This is a commit hash. And to see the content, you do dash p, and you see the content here. So it says the parent is this. So we can go to that parent here and see its content. So this is of a different tree. Again, if you go to the parent, so if you see git log again, this is what was going through the tree, right? Because we did 042 and it's 042 here. So it is like a link between these commits and each one of their own. For example, if you take this is the commit message, and this is the format that Git uses. The type of the which tree does this belong to? Which parent tree does this belong to? This is unit tree. Let's put this. Okay, it's a comment. So where do view trees? You get tree objects. So yeah, you can even take a blob and whatever you can do the cat file on that. Okay, tree allows you to store a group of files together. Can we do this similar to what we did? Was this dash p? This is main, right? This is a main. If I do dash t to comment. How is it a comment? Yeah. So this shows the tree here. Yeah. That shows us a tree. So in this we have this blob. So this is a blob. The actual files are a blob, and the folder is a tree. So we create a tree object for this, and if we see in that, um, show this, that should list the files of this tree. So if you see inside SRC here, you'll have the same files as this. But the important thing is these all belong to. So these are the hashes of these files, and these all belong to one tree, which is the main right now. So we take some commit, right? So that would be another tree, I think. So if we do git log, we take some, let's say, let's put the first commit, and instead of the main, if I do commit, you can see that this is a different tree, I guess. Let's do the normal main. See, the hash is different here, and but the folder is same. And if I go back and view this tree, there's only main.zip, right? But if we see in this, we have all these files, not just main.zip. So the thing is this, the commit actually represents a different tree, and this is a snapshot. Like if you want to go to that commit, which we do in GitHub, this is what happens. Like because Git has all the information, and so how do we implement this? That's the point here. So let's go one by one. First, we'll be implementing the tree, I guess. Tree and blob, I think, is a good way to start. That should be tree. And let's see. First, we can just take a file, hash it. So that's how we create a blob, right? And we can compress it, but right now we don't want to compress it. We are going to store it as it is, but the file name is going to be um, the hash of itself. But how is this useful? So if we have a blob, maybe we can take some command and then we can implement it. Is that a good way? So there is git add creators. I think we can do add. We can do what do we do? Commit is one important thing, because when you commit, it creates a tree, and you can use that to, as we see, it's another tree. So is git commit a tree? Yeah. So a tree exists instead of a commit, right? I mean, it exists in the Git folder, but in order to use it, Git uses commit because the trees are referenced by the commit. So if you go here, maybe we need to have a tree object which can be referenced in this commit object. So then we can just check the tree first. What do you mean by tree? So basically, we're going to put in some directory, and then so let's say if you have dot git, right? A dot is not properly functioning. We have a dot git object. In that, let's say I have three files, dot a.txt, b.txt, and c.txt. We have these three files and an src folder. So with these three files, the git objects will hash all of this. So my question is, how does this hash the src object? So when it sees a tree, I think it just hashes it. Let's see how does it hash. So in this case, we want to see um, how it hashes the folders, right? So let's get the tree of that. So let's say if you're in the main, right? So this is a tree. Let's search for this and get DC4. You go to this objects DC. It stores in different hierarchical directories. We have DC, yeah, 4BC. So we have it stores that. So this is a tree. But if you view this, this is the content inside it. So it's actual tree, right? So this is the actual content inside that. So it's going to be recursive kind of thing, right? Because what is this hash? How is a directory hash? That's the first question. Okay. My question is, how do you hash? Is it like it's a hash of the hashes of all the contents? How is a hash for tree calculator in Git? Yeah, this is what I want. Yeah, so hash of a blob is just on its content. Simple. Ah, okay. So a tree is actually it's a hash of this content, right? It's nothing more like it's just text of this, and we can actually refer to this tree and see that this hash is calculated based on these contents. So if I change the folder name, nothing happens because the contents of this folder is same. So the hash is going to remain the same. But if I change anything inside this, the tree is going to differ because we have updated this, right? So that's the thing. So I think tree object is clear. When we create a tree object, so there are two things. Before even committing, we need blobs and trees in order to reference that in the commit. So if we take the tree object here, this is a main tree. It contains an SRC tree, right? The branch itself is another tree. I think we can get to that afterwards. So we did have we do have this tree object. I'm thinking like, where do we start? Where is this? Yeah. So yeah, we have this, right? So we hash this. We have this. When you do git commit, right? What happens is that you actually create hashes, I mean directories inside the git object. Or do you do that in add? Yeah, I think git add does that. So um, when we do git add, right, we take this, create a tree out of it, the root tree. And how does the root tree store? I think that's fine. The root tree is actually the tree of the main. Let's call it main. And the a.txt has a hash. This is a blob. We create a blob object, create a hash, store it in git.objects, right? Let's say the hash of this is abc, bce, cef, bcd, and cde. And src is going to be, again, it's a different thing. So it's a tree. So we're going to go into src, calculate all the files, and return that back. Like if there's a tree inside that, we are again going to go into that, again bring it back, right? So src is going to be, let's say, zzz, and this is going to be a tree which has, let's say this src has two files, d.txt and e.txt, right? Then the hash of src is going to be, let's say d.txt is something like this, and e.txt is something like this. So this is going to return of type blob, and this is going to be the tree. This is blob, but actually we don't store what type inside the git objects. This is not needed. The content of this is going to be like this. So inside this, the content is going to be the a.txt. So now, what do we need to do? So let's ignore trees for a while. Let's do the blob thing, right? Let's start with the blob. And before that, we need a number of things to handle, which is the command line, because we haven't started the project yet. So let's actually get started. I have no idea what we're going to do, but so let's create. Since this is zig, we don't need to have a specific folder here. We can just go into dev, and I can say, do we say git zig or zigit? Yeah, zigit is cooler, right? Zigit. We're going to zigit Emacs. So now I just say zig init. I could have done zig init, but I think it's fine. We have this now. Let's actually do git init here. So, and now we have this. I'll just remove everything here. And how do we are going to build? Just set that up. Let a made file to build. Zig build. I think zig build should work, right? Yeah. So if you're going to run, then you're going to do zig out bin zigit. It's going to be like make, build, and make run. Fine, that works. We'll add a dot get ignore. I want to say zig out. That goes away from here. And now for this module, I mean, what are we going to write? We're not going to be using any of the external libraries, I guess. For hashing, I have to see how we're going to do that. But I think it's fine. So now, what do we need to do? We have the structure set up. So the first thing is set up arcs, create get module, create submodules, and get. I think it might be commands, I guess, and get. Let it be get. So let's go here. I think we have to see zig arguments. I think zig is going to be much harder to slower. I think the dev speed is going to be slower than Go. Okay. So can we do this? And when we make run, we can say add and dot. Let's see. Yeah. I think the makefile needs some update because it needs to pass the arguments as well. Pass args via make. I think with this. Yeah. Okay, I think it might be because I think let's go this way. Let's just do make build and make run it. So not make run. Let's figure out check it. Yeah, we could do that. And we have to loop through it. I think we can just can't we just check if standard.os dot rb of let's say 1. Can't we do this? We can also check the length before this. Length is greater than 1. We can do add. Actually, if it's greater than 1, I want to do a switch on rb of 1. Let's say if case, okay, I think it's case bit. What? We do switch on strings. I will just do it for this. Come on. How do you compare this? How do you compare this? Is it equal? Yeah, I think it's equal. U8 and it's going to be was dot argv of 1 and then git. Let's print git. Okay. Wait, can't we? It's not const. Can I do this? Maybe we need to see like it's very hard to compare strings here. Did I put zig? Yeah. Even Facebook has this. Oh, it's CS50, so it's fine. There is zig if even asking. Oh, how do we compare this? Type is not a function. Okay, that's fine. Let's do this. Do you want me to use this? I don't know if it is valid. So equal takes the comp time. It takes a constant this thing to convert. I need to convert this to this. Six. Std mem span 3.was dot rvf1. What does this return? This returns a slice. Can I use this? Yeah. Yeah, I think that works. So we could do our comparisons like this, and We would just one is going to be this. So it's going to be this. And R2 is going to be this. And I'm writing this on my own. If it's not, this command needs to exit this. Wait, yes. Process.exit. Status is going to be 0. Actually 1. So if I do this, it just got this, else it exits. Yeah, it works. What did we do until now is that we just set up a minimal CLI example, like we just got this commands working. So now our job is to implement. We need a Git module, I think. How does Git structure? Let's remove all of this. Yeah, I think we need to see how it's structured, how people do this. I think a good example would be Ghosty, but let's go to, I think it's Ghosty or what is it? Okay, Ghosty org. This is written in Zig, so we can go into the source. These are all, I think, separate Zig things. Maybe we have this one entry point and then they do that. It's fine, I think we can import it. So if I do in SRC, if I do git and I do add.save, how do we export this? So let's say if I have a function here. So this is git hello. Let's say hello from git. How do I import that? I think I can do git slash add. Let's say I can do git dot. I want to add.sig, I guess. So if I do this, let's try. Why is it not saying hello? Yeah, I think it works because I haven't said anything here. So that's how we want it to be. I think this works. So let's just click this. So Does Git have interfaces? I mean, does it? I think inside Git we need let's say git.zig, which actually has this function. And this has a function. Let's say public function. Let's say add. It returns anything. Doesn't return anything. And now I can actually this calls go to main, pick this up. I think it's just add.zig here. I would just call git hello, right? And now in main.save, I would just get and I would call it like this here. I would just say git dot, I think this should be pub, I think. Git dot get, and I do that. Try here, see. Yeah, it works. So this is much better because we have a central place to handle all the commands. So this will call add, I guess. Let's say git add. So we have this, so we need to initialize first. So we'll be needing to create many files and folders when you do this git init. So let's create an init function here, and let's create an init.zig here. Let's import this standard, and we'll have a public function git init. Or I would say, just say init. And return an error here. What? I think we need to do void. For example, let's say void. And when we do git init, right? And just do init.zig, and here we could just say git init, or we could just call it here init, or just say git init, or maybe just git init. So in this init, let's print something. Let's pick something from here. Let's just say git init. Oops. Right. So if it's git, it comes here and it checks the R2, and we need to compare this again. Kind of messy already, but we need to compare this with init, and then call that. Maybe we have a better way to do this. We can have some kind of I can just pass in the init and it'll automatically call that. But can we do that actually? If I do, how do people do this in this? There is a command which is going to be u8. So we create a git with a new, and then we type in the command here. We can say if we can just match it, right? We can just say else It doesn't need span here. Let's say if it equals this. If it equals init, we're going to call init. So this doesn't need to be a public function, which is a good thing. And we go here. We could actually say just this, which is get.new and the arc2. But we might need to pass more commands in that. Like we need to pass arcs for this particular command, which is going to be, can we do this? Is this even valid? I think I need this. This is going to be arc2. Now, okay, it doesn't support this. So we need init with arcs. List of. Actually, we need to get all of them, right? So let's say list of 2Ds list zig. I need to use allocators maybe, but until now we are using just static strings, but that is fine. The arcs, can we do this? But they don't allow us to do this here. We actually need remaining arcs. Arc V, and we go from V to this. Get remaining elements from array Z. Usually that is possible, I think. Is it like this? What type is this? Sure. Okay, do we need to again convert this to this? Now this type is going to be, what's the type? So here I think, not sure, but can send that here. So get init args with args length. I think we are making it much complicated, but for now, let's just do with no arguments. Right? Because init anyhow doesn't need an argument. We might need to come back to this, but yeah. Yeah, I think we can go into init. So we have this git init now. So now we get the git init command. Um, so I think there are a couple of things now we have to do. One, create dot cgit folder, create dot cgit slash objects. So what do we need for initialization? We need to create a main branch, but I think let's just create these two folders for now. I think we can go handle get this. Let's actually print what's the current working directory. Okay, because current working directory. Okay, it's a file descriptor. Sorry, don't need that. You even get that. Okay, I think it just used to create it. Okay, let's actually do that. When we do that, we do make directory, which is dot cgit. What is this w? And we need dash objects. So let's do zig init bit init. Where is it few? Do we need something else? Missing something. So maybe we can do make path objects. But I think still this will fail. Yeah. Too few arguments to the right, or what does that mean? File is not created. Are we printing anything? Okay. Yeah, it has created the gate. It even has objects, which is an empty folder. So that works. So, what if we run it again? If it already exists, will that fail or break this? I think it's fine. It just runs fine. So we just create this, and now we try to track all the files. So the first thing we need is the git status command, but I think that actually needs a working tree in order to see what's happening. So for that, let's see, how does git status work? So We're going to we might do the status command, because when we do the status command, right? So do we have status here? No. So when we do the status command, what actually happens? So we have this working directory, right? So we have this. We go through each file and we see in the .git/objects if this exists. So we hash this file, see if the hash exists here. If it doesn't, we show that this file doesn't exist. Let's actually do status.big. Let's move this to this. So what we're planning to do is, actually let's put this in grid so that we don't forget that. So we're going to do status. So we could try status. Yeah. Actually, it's grid status. So I think this should work if it matches status. And status doesn't need any more arguments, at least for now. So the first thing is we're going to walk the current working day. And for each file, we're going to hash the file content. Let's say this is 1, this is A, B is going to be, we're going to check the hash, check if the hash exists in .git slash, I think it's .zgit, right? Slash object slash hash. If it exists, I think for now, if it exists, check if, how do we check if the contents match? Because here, I actually read this command, it basically says what it does. There's a file in the repo. Okay, if it's a new file, then it reports as untracked, which is what we do. The first thing we were saying. If there's a file in a repo that is not in a tree, then it reports as deleted. If the file is present both in the repo or another, it calculates scan of the file on disk. And if it's different from the file sharp on repo, then report that's modified. How do you do modified? Because isn't the hash of the file the file name itself? And if you're matching it, isn't it? How do you do that? If the file is present both in the repo and on the disk, then it calculates the SHA-1. Okay. Let's see this. Is it like the tree has changed or something? Yeah, tracking that might be a bit big task, but for now, what? So we are going to check if the hash exists in this thing, in the object, and if it exists, show green. Actually, if it exists, do nothing. Else, show the red text of the file. 3D out. So if it exists, we're not going to do anything. If it doesn't, we just see that. But if you have deleted, I think if there's another case, like so it exists in tree but not in on disk, deleted, right? So we have to know which tree is this. So git status, we need a tree for that, right? Don't we? So if we do a git init, it does git init do. So does git init create a tree? Yeah, it creates a working tree. So what do you mean by working tree? Okay, I think for now we'll just go with this. We'll see the edge cases later. For now, we'll just go through this. I think we might be needing utils, utils.sig. I think I'll do hash.sig. Maybe so my doubt is how do we create a working tree? That's the we have to see the git work tree. Let's see git in it. Okay, and so what I'm trying to see is what does the initial branch do? If we do git init, so we have done git init here, right? If I do git status, it shows these things. Let's go inside git objects. We don't have anything inside objects. We don't have anything inside this head. We have a head which is pointing to main branch. We have a config and we have a description. We have info. Have hooks, but nothing important. So how does git say that um okay, I think git status, I think we can come back to that, but for now I think this should work. Can we do the same? What was that? Not add, it's init. Can we take this work? Yeah, linear allocator. Can we use an allocator from git? Let's go to git and create. First, we need to create a new allocator here. Wait. Go here. Go to this. How do we create an allocator? I don't need an allocator. I just need an normal fixed one. Yeah, general purpose allocator. I think that's what they call it. So for new, I guess we do this. I don't know if we can do this. For status, I'll just throw in this cell. What do you do? Structs with self. We have self is it. Oh, we just use that itself. And just save it. Let's get status with self.allocator. And here we want to take an allocator with just print. Try running this. Okay. We need to just pass in this. Oh wait, do we need to just do um, what type is this? An allocator, right? And when we're doing new, we just say okay. How do you create allocator construct? It's very so we go zig allocator on what so yeah. So init, yeah, init is the thing I think. Not new. Init. It's just z init, z status and say that. This init will take self it. I'll just do self. And here we can just send this. Yeah, we need to change the main and we're going to init this with the command. What do we call this? I think we need this, right? This trapped and wait. How do we do this? Try git dot get dot. But that shouldn't happen because you're sending this. Okay, does this have a new function or something? Or we have to return this? We might have to return. That doesn't. Wait. So what I want to do is I want to init this. Maybe call. Just want to init this. Need the self because I want to do this. But I think we need struct for that. Is there any? Where's the struct? Struct. Where's the struct? Yeah, we have this. So in it, it's going to be taking this. Yeah, this is how we want to do. So what we want to do is ref this. The init is going to return this thing. Get. And we're going to just return this. Allocator is going to be this. And let's take the command as well. But I don't think we need command here. It just initiates it. And we can just have another function called call with this. And just move it here. And maybe we'll have this self. Okay, so here now we're going to say try uh, get dot init. I'll say const g is this and p dot wait. Yeah, I could do. Okay, do I need to do this? So this returns as a get. So this is going to be get dot call. Command is going to be m dot span dot was dot argv of 2, I guess, or just arg2. Okay, maybe we don't need. Yeah, now self want z init is not a member function. Okay, why is it? Okay, it's because maybe we need this. And how do you not make it unused? Because I do not use it, but I wanted to be a member of this. Oh. Now we have this. call. We have to try this. Yeah, so now we have a walker here. Next, for walker.next, we have, I don't know, let's say x, and we try to print it. Let's print it in a new line. Vector type is this, found. Okay, do we need a var here? Wait, well, let's walk directory in Zik. I think that's what we did here. We tried walker.next, but that throws us that not indexable. Okay, do we need to init or what? I think we forgot actually in git. Let's say we need to have an init function. It doesn't return anything. It just uh, closes this allocator. Destroy. Wait, how do you close an allocator? Okay, I think it's init, right? No? So we take the allocator, we want to close it. How do we close it? Or does it do it by itself? There's no D in it here. I have to come back to this, but actually you want to see the actual problem with the walker. What's the problem here now? I don't understand. The follow must be range, array slice, tuple, or vector. Okay. So here, yeah, we try to wait. Do we need an allocator? Yeah, we do. We give an allocator here. So we have this. We can copy that, but we just want to see a proper way to do it. Oh, is it binary? Yeah. So this gives us 3 arguments. What is it? Entry.path, base name, what else? Directory. Let's just print that. What want? Expected 2 arguments. Ah, okay. I think we have to do this. think we can put value or any, I think. Okay, we don't have anything. Let's do a.txt. Okay, I think we have to run status. Okay. Iteration permissions. We need an iterable diagram. Okay, I think that's what we were seeing here before. Right? Yeah. This is what we want. Yeah, now it works. So we chose all the files, including .get. We have this. It shows us everything, the path and the file. We just need to open the path, get the contents, hash it, um, create a file for that hash, and put the contents in that object. So we need to ignore some. So I think we need to ignore .get. So if let's actually create some ignored paths, which is going to be .get if string and slice break. Which we need this ignore paths. Right. So we need to check if something is in so non-existent fruit. Do we need to check that? Okay. But we're going to go through ignored paths. We get a path. If we're going to compare it, it's going to be u8 path, and we're going to compare it with, I think it should be x dot how do I know if it's containing this? Can we do contains? It takes pump time, haystack, expected count. You can does this even compile? Yeah. If it contains, then continue. So right now we don't want dot get. Still dot get, does it come in? The cache also is there, right? We aren't actually implementing yet, but we are trying to get it out. Yeah, I think. Okay, again. Why does this come in? I think it's got path and path here. Um, and Okay, do we need? Oh, okay, I think we should. We don't even need this. We just need to check if ignore paths. I think we can just do this. Actually, I'll take the utils and utils.sig. Don't want to write it every time, so I'll just pull in the standard from main, and this will be a public. Is string and slice. We got that. I think we can just use that. How do we use it? I can say if utils dot getting this. Now I think it's you. We go back and do utils. Utils. There, let's say this. A stack is going to be node paths. Needle is going to be extra path. Is it? I think we need to match this, like we need to sub. Do we have? Okay, I think we have the index of this is not equals to none. We're doing it the correct way because we need too much time to do this. What I'm thinking. So for one, I think we might need to check if it's actually in the subarray. Subarray 0 means it's not present. So if we have this, wait, are we doing this in status and are we doing this? Yeah. We are going through each file. We have this ignore paths and we are sending the path. I think it should be the other way, right? Oh no, I think we find the path here middle for each slice, compare the index. If we do this, yeah, that works. Finally, let's do this, and now we have everything here. I'll just take this out. We don't need this. So yeah, we have these files, right? And let's ignore some more. I think there are a lot of files. Let's do .cgit. Let's ignore. I think it's a build, right? Let's remove the zip out as well. What else do we have? We have this necessary. We have make file build necessary. I think yeah, this works fine. Um, Now what we want to do is we want to, when we do status, I think it should just compare. We need actually the hashing. What algorithm does get used for hashing? We need to check that. Let's just use SHA-1 in Silk. We have this SHA-1 here. So what you're trying to do is now we need to hash the file contents. Like we need to see dot fs dot read. How do we get read files? It must be something around that. We need to do open file. I think we need to do open file. For the path, we're going to do export path. For flag, we don't need. We can just dot mode is read only. So we can say const file contents. Let's try this. Right. Then we can do defer file close. Let's just rename this to file. So now we are trying to allocate the buffer size to the allocator, right? So for this, now we need allocator. We already have an allocator. So now for the allocator, we are going to get stat of this file. Then we do stat dot size. Let me do this. The font size is going to be this, and we need to allocate. How do we allocate? So we can do self. We have the allocator dot alloc. We need u8 and the size, and this is a buffer, and we have to defer allocator dot. What do you do? Init. I think that's fine. Try file dot read buffer. And I think the buffer will be stored inside buff now. So now we use SHA-1 to hash it. So this is the buffer, I guess. Right, what's the out? I think we need hash to be of type 40 u8. And now it's undefined. And here I'll just show hash out, I guess. think I can just do the empty thing. Let's see if this compiles actually. File dot read. Why did we ignore this? Okay, unit 20 is fine. Okay, you need it to be, yeah, we can't put it as const because we're going to modify that buffer. We are getting an error when you try to read the file. Error is directory. So if it's a directory, we have to ignore. Fine. How do we check if it's a directory? X dot. So if you see in this previous things, I think yeah, file descriptor is different. You have to see for files like we have src. Where is src? The 4 and it's a 5 for files. No, I think it's different. Check if path is a directory. We need to check if it's a directory. We can do open there and then okay, we get the error. Need to. So we have opened the file here and the error. How do we get the error? Okay, can we do this? I don't think that's going to work. Yeah, because it's default or else. So it's giving a file. Oh, I shouldn't do try here so that I can catch that. Catch with this. We're doing read-only mode. Let's remove that. Why is this giving us? Okay, I think we need to run false. You need to return the file, right? Now we need to. What does this return? This returns void, but I think it. Wait. Let's do nothing. You don't want to. Wait, should I put? I think probably we'll need this because that's a separate function. and I'll just put it in utils. And for this, let's use try because that doesn't make sense for me. So if just a second. Um, so if utils dot is directory is going to be what? fs.cwd path is going to be sx.path. So if it's a directory, we're going to return. We're going to continue. Maybe you could have done that here itself. We should have used continue instead of return. But yeah. Are we getting the hash? Let's do this. Hash out. Yeah, we're getting the hash, but why is it not in string? Okay, it's what is it? Okay, it's bytes, right? Why not? Why not a string? Why is it? Yeah, we need this in hex, I guess. What? We need hex to byte. Um, see this. Let's go. Wait, what? There's no implementation here. What are they trying to do? That's what the people come for, right? Come on, give me some implementation. Slash Java dash. We do any. I think if we do any, then we saw I think what comes out. It's just a string of bytes. Yes. Okay, it's alloc print. Let's try. I just want to see the output. Nothing more. And it's hash out. Let's print as the hex string. Wait. It still gives me this. How do we? but we are able to hash it. Convert it to string. How do we convert it to string? And we do that. It won't. Let's do hex to string fig. It's in hex, we know that, but I think it should be something in the lines of this dot format dot hex this dot decode hash out. Wait. Just write it to this buffer itself. Why is it? Just sometimes give me something that's very old or something that's not there, but that's the problem with this uh, summary thing. I know they should want. How do we do this? Why is this so hard? Ah, X array to string and set. Is it just hex? This returns what do they even want? Formatting is not working, so must be something else. Is there anything other than this? So I want to convert SHA1 to string. Or should we just go and see? We're doing something else here. We just call the hash. Um, yeah, I think they're just doing this. Let's write this. Yeah, now we get it. I think this is fine. This works. So now quickly we move to creating this. In how do we do the? What did we do? I think init. So we just say make this path. Wait, is this CWD? Let's just do. I think we just need current working directory as this. Just don't want to call it every single time. And we have to change a couple of places here and here, and we are going to make path for how do you do string formatting? I just need slash the hash here. String formatting a buffer. Yeah. So I know like how the size of the buffer is going to be. So I'll just do this. It's going to be, so this is how many characters. Let's count the characters using this tool. So this is, count it. Yeah, 40. So it's, if you take this 40 plus this, right? This 16, so it's total 56, right? So just need 56 byte buffer, and we're just going to print it like this. We're just going to print it slash that zigit slash dot zigit slash object slash s, which here it's going to be the hash string, and I want to make this path. And if we go here, we show the hidden files. We have objects here, right? It is fine. And inside this object, we make a path here. Gives me, I hope it's function. Just give me. It gives me an void, but this is the path, the formatted buffer. I want to say new path. So we need to check if it exists or not, but that's fine. Let's say check new path like this. So now we make the path, and to making the path we have to, so in git, right, we have this object. So let's go to some other folder. So in this I have this git. I go to objects. Wait, there is, wait, why are there no objects here? Usually there will be objects, right? Let's go to 8-bit CPU, and here we have the object. We go into this, it's a file. So let's create a file with, we don't want a make or make one file, and we need to create a file. And this would be just this. Let's just throw another, no. We create a file. So this returns me an open error all the files. So I just need to say file, right? So this is the file. I want to write the contents of this file, which is buffer. So I go here. Can I do this? Yep. So I run this again. It's like this. Wait, what? Let's go back to sig. And now, yeah, it works. So there is the files. Everything is a blob here, right? And if it's a directory, it's currently empty. because if you see DA39, where is it? DA39. Yeah, it's there. Okay. Okay, if it's a directory, we're skipping it, right? That's fine. So for now, I think, yeah, the objects are being created. Yeah, we can actually compress this because this is a type blob, right? We can compress this, but now we have to handle, I think, um, so this is git status. In status, we are just showing if this exists or not. So here, actually, what we are trying to do is we go through each of them. We don't need to write file right now because we just need to see and if it exists or not, right? So we need to check maybe if current working directory dot exists or has. um I think we can do this. So what we want to do is we want to create new path here. So we try to open the file. If the file is not found, we display um red string thick. We do red string. It's a literal red string, but let me do that. I don't know. Let's just do this and the new path, or else if it is present, let's green. We need a green escape code for that. Escape code for green music. We need this. Just try this. It it doesn't show us, but what if we stop this? Okay. Let's print a bright green text here. I think this is not required for now. I'm just doing it because I want to. I think it should be extra path. I think it doesn't work, but let's do plus or minus. I think that's more simpler, right? Not staged. Staged. So if it's already there, then let's just put exist for now. What does it do? The git status print here. Actually, let's pull it back here. And do the same here because it's much more cleaner to do this way. And before that, let's go and delete everything here. Okay. So now it's fine, but we need the actual path. This x dot. I think it's a base name is fine. Did I be creating anything? Okay, we are creating it. Don't want to create it. Now I think it should work. Not staged. Not staged. Okay. Now we need to add git in order to add the file or folder to their respective directory. And this works, I think. For now, we need to port some of it to add because we unknowingly committed that to status, but um it's if you're going to add something, we need to add we need a argument for that, which is a path. Right, so let's copy everything. We don't need everything. Actually, let's keep it cleaner. We need the current working directory, I guess. So what I'm trying to do is let's actually with the path, I think we have to get create a hash of the file paths print. We get a hash, use the hash to create dot cgit slash object slash hash. If it exists, um, still create it. And I mean, it doesn't matter if it exists or not, we just push it like we create it. So if it's a file, create it, create the path. If it's a directory, then what? That's the question. For now, let's do the file part. We have the path. We just need to read it. We actually need these imports. First, we need to open the file. Let's open it. CWD, we do need it. And the path is going to be the path. And for now, let's not use allocator here. But we open this and then we try to read the content. We create this and then and now we need the allocator. So we have the buffer. We try to read the buffer. We are trying to create a hash of that. So I think we can move this to a common function in utils. I think there's a hash.zip, right? So we get the hash string. Now I think we need to check if the file exists, and we don't need to print anything. We just need to create the file with the contents. So the path is going to be the path. But my doubt is, oh, we need a new path, I think. We need the new path because we need to store that in the Zigit folder. So this is going to be new path. Um, I think if the file is not found, I think it's fine. So, so there is this in Git, we need to add this. We need the path. That's the problem now. I think it's self dot getter. We need to enable self here, and the path is going to be the path we get here. So wait, do we what do we do? Git add. I think we can just say git add. So the path, I think when you create this, we need to do add, and then we can just say z add. So the path, where do we get that from? So let's see, how do we pass extra arguments? Okay, is it so? I think we need args dot. What do we? Yeah, this is no, I don't want to loop through it. Is there any better way? Because we need to. What do okay, even if I send it, like if I have this main, and then if I send multiple arguments to call, if I say this remaining args, is it acceptable? Yeah, I think not acceptable because too many tabs here. I guess so what I'm trying to do is somehow I'm trying to send this remaining args, like if I say git add dot, I want to be able to send this dot here, right? I think I can remove git, but wait, why am I doing git? Or maybe because if I have the add command directly, then I can just send it via arg of 2 or arg of 3 directly. I can do that, but it would be, what if it's just in the args? I think that is better, right? What if I just do What if I just do this and I get that here, and now the command is going to be mem.span of arcs of 2. Now if we can do this, yeah, we could do. And now if I say for the add, right, this is going to be, let's say 3. I'm going to say this, because if I do add dot, yeah, now I mean, yeah, but I can just print it to see if it's, just say add path. Okay, need the format specifier for this. Yeah, it's an error, but okay, let's do makefile. Yeah, so it doesn't support what do you say, directories for now. Let's try doing git status now. So the makefile, where is the makefile? If I do status, so if the error is nil, I think it's null, right? How do you see if it's null? So let's go to open file. We get an open error or we don't get an error. So I actually don't want to, where was that? Yeah. Where do we want to do that? If I'm opening a file, if it's not there, then fine, but how do I? There are multiple errors here. We just want to, we have checked for file not found. We just want to see if it's null. Not sure how to see that. Maybe we can just do file, if our file dot close, then just say this exists. $47. Okay, what does this do? Okay. found void. Okay, I think it's because, can we just do try and with try errors. If I know how, I'll just see how it works, because so that it's more of a zig problem now. What I want to do is I want to open a file. I can just do try and I can just remain calm after that, right? Say that's a new file. So file not found. Now new file dot error. Let's see this. Right. Yeah. So this actually has to be in a separate function, I guess. So maybe we can do if this gives a file, else this gives an error. We will do a switch on error, new file. Prefer new file dot close. If it's a new file, then we just say it exists. Else we're going to say it's not staged. It's more file not found error. Wait, maybe like this. You have to handle the else cases, I guess. It must be in one of this. File not found. This is weird, but let's try this. Yeah, if you see, we have this make file exists, right? Because we have added that previously. And if I try to add uh, utils, I guess. If I try to add, let's say src slash the main.zig, if I see the status, you can see the main.zig has been added to the working tree. Now, when I commit this, I commit the current working tree. That's how we need to figure out. So for now, we have the status and the add working, but the one thing is, if I do src slash utils, right, it's a directory and it throws an error. So we have to see if it's a directory. Let's see, we can handle that. Where does it show that it's an directory? Yeah, I think it shows us here. Let's try. Okay, where is this happening? In add.zig. Oh, is it in add? Yeah, yeah, yeah. In add, I think line 20. So this is where we are trying to open this. So we didn't check for the directory thing. So we do this. If it's a directory, we currently return. Yeah, we don't do anything. So actually what we want to do is, if it's a directory, we need to walk through it. And so we need to create a walker on this. So the directory is this. Yeah, the path. And we walk on this. We try to, for each file, we're going to add it. Right. And if it's a directory, again, we're going to call this. Let's try that. So if it's a directory, then we call uh, add, I guess. Like x.path and the allocator. That should do. And now for each file, we're going to do the same thing, right? So maybe we need to hash and store the path and the allocator. So let's use a void. What we want to do is, we are taking this early. Let's take this and we want to do this. I think that should be good. Hash and store the path and the allocator. We'll try in the else block here. See, okay, we have to. Oh, here we need to try this. So for utils, we're going to try to add it continuously until we get a file. So right now, if I do status, so and if I do src/utils, we don't have this utils.zig and hash.zig. It's not staged. It should actually be staged if I try utils. It's not being staged. So if it's a directory, do this. Should we print something? Let's say adding recursively. So this is being cached. Okay, it's else. You just hash and store. X dot path should be good. So there's file not found again, and this is from 8. Wait, what is the path? I think it must be some path issue. hash.zig. I think we must just send the directory, we send the path. If it's not the directory, we're not sending the path. The base name is giving me. Okay, if it's not a directory, we just. Okay, if it's a directory, we go into the directory. We're going to hash.zig, right? So I think it needs which directory it's going to add. That's the problem. Can we just have a function or x.path? Let's try to print. Not printing adding recursively as well. Where is that? Print adding recursively here. Yeah, we're coming in here, and since utils, we are in utils. Each file is a path, and it goes in here. Let's see, hash path. Let's just say x dot base name, x dot path. Should be same, I think. Hash dot say. Why is it hash dot sig? Both of them are hash dot sig, but it's because we are sending it here in such a way. So here we immediately trying to see if it's a directory. I think we just need to call add x dot base name allocator here, because let's try that. Actually, let's try. We have to try that. Yeah. What if I do path? It's not having the. Because I'm not getting the proper path because I am iterating through it. It's not having the original path. So maybe I need to. But if it's nested, we don't know which path it is. Do I not have anything else? I'm not getting the entire path. Um, get absolute path when walking a directory in Quick. So try to walk. Relative path is this. Absolute path is this. But I don't think it might work. Let's just see. So base path is this. Base directory is this. I think yeah, we need to add it to this. Don't know if this will work. Let's try with this one first. Base path is this. And the relative path is x dot path. Base path is this. Absolute path is this. Yeah, I think this is fine. The hash path, absolute path here. Yeah, that's great. That works, I think. Let's try to go back. Git status. But yeah, now you can see this is existing, right? Both hash.sig and utils.sig. And if I try to add everything in src, which is let's actually go back. Let's delete this. If I do git status now, anything is not staged. If I try to add yeah, if I try to add utils, and if I try to git status now, see two of these files have been added. And if I do utils here, it might be src/utils. There are two files with this. And if I do src, you see there is a git file. And if I do git all these files, if I try to add the src itself, and now if I do git status, you see most of the files have been added recursively, and the only ones which were not added was outside of the src folder. And I think this is great because this works as expected. This is what the actual command should do. But I think this is good. Let's remove the prints which we created. We're printing anything, yeah. Yeah, I think we have this what is it, carry draw. So we have status done, right, for now, and we have the blob is done as well when we are adding this. So when we add it, should we create the tree? Yeah, I think when we are adding, right, we are creating the blobs, but we should also take care of the folder. Like we need to create a tree object for the folder, right? That's what we need to do. What I mean by that is when we are adding here, so we see if it's a directory, and we go through all the files in the directory and try to add them. But we're not creating the tree object. This only creates a blob object. Creates blob object recursively. That is good because blob is that's the actual entity which everything is built upon. So if we have the blob, next thing we need to build is a tree. And if we have the tree, we can build a commit, right? So now we are creating a blob, and after creating the blob for all the files, we need to make sure that we create a tree for all the blobs. Well, create a tree in the sense, now if you see here, right, if you see the status, everything is great, but we don't see a tree or we don't see the src mentioned anywhere. Everything shown here is a blob, and we don't have an src here. So So in order to do that, we need to create a tree and say that um, all these blobs exist in this tree. Like for example, in src, right? Src is a tree. So these four files exist in src. These three blobs, actually they're two blobs. The other two are again, they are another tree. So we need to recursively take care of that. Like whenever we hit a directory, we have to make sure that we are going to create a tree out of it. I think we need to um, update. What's the format of the blob? I'm not sure. Format of it blob object. Um, okay, so I think that's good. So for now, we need to create a tree for whatever blobs we created here. So for if we want to know what the blobs have been created here, we need to return it, I guess. So when we are adding this again, we're finally doing the hash and store, I guess. So this hash and store takes a path, creates the blob, and doesn't return anything. We might need to return the hash. What I mean by that is, so let's create a type here. How do you create? I mean extract, right? Yeah. So we need to create, let's say, um, by struct I mean. So the hash and store should return a blob. This should return a blob. The add must return a tree, right? I mean, we don't need to use the tree, but at least to use this, we need a tree. If I say um, where tree is a struct, and we have number of blobs in it. So this is going to be, I think we need an array list for this. So if we, so basically what we need is a tree, and it's an array of, it has an array of blobs, of all the blobs. It should actually be path to blobs, I guess. Maybe a map of the path and the blobs, and path and trees. Or maybe it should be just an object, I guess. So we might need to move this out of add.sig and into git.sig, I guess, because we need a tree and a blob object to exist so that it's much easier for us to read and write these objects. I don't think we need this, but if we have this, it's much easier to return from the function. Let's create it. Let's say where, but the problem is we can't define it exactly as it is. Tree hash, blob hash. I think it's on Q8 versus 40 character hash. I think it was the same here, but so do we, the only thing to differentiate is one is of type We just need to identify them as blobs and trees. So what does a tree have? Tree. Let's go to tree. Yeah. So tree object has, yeah. So there's a blob, there's a blob, there's a tree, and inside that there's a blob. So it's usually mapped to more blobs and trees, right? It can have number of blobs. The blob is nothing but uh, this can just be an array. It's an array list. Not sure if it's an array hash map. So this is a root tree, I would say. When you're adding this, so I put it here, make it public. So the root tree is going to be, what do we do here? So the blobs, do we only need the blob hash? I think that's array list of constituent. Maybe trees is again going to be the list of objects. Let's say tree, not root tree. So a tree currently has the blobs and trees. I think we will work with this. So when you are hashing and storing, you are creating a blob, right? So you want to create a file. So you want to return a blob here. So you are actually returning this, not a void, but a blob. So it's going to be, it's going to be a struct. It's going to have an hash. So blob is going to have an hash. So we're going to take blob from this. The blob has an hash. The content, I think it's fine. We don't need to store it. We just need to write it. If you have the hash, we can just take it from .get slash objects. So we need the blob, we need the tree, and blobs are going to be list of blob. Again, tree is going to be a list of tree. I don't know. List of tree. I don't know if that will work. For now, let's just say it's list of hashes. This is going to return blob, and we have to return a blob with the hash as hash string. I think then we actually get the blob here. Then we have to create a tree and then return the blob in it. What do we do here? We just create blob. We need to use this blob somehow. I don't know. Both of them, they are an object, but what do you say? Inheritance in six structs. I think it's doable, but I'm just thinking. So if we have the blob here, we are going to return the blob, and this just adds the blob, right? Let's just return a blob, and with these blobs, we are going to create a blob. It's going to be of type std.arraylist of blob. Then it should be init. Let's do arraylist zig. Okay. I think we can do. Okay. Let's do dot empty. And when as we get a blob here, then we just push it here. Blobs dot append locator and a blob. Right. So we have a list of blobs here. We're going to create a tree with that. But um, if it's a directory again, we will walk through everything. The path is what marks this as a directory. So we want to create a tree here with this tree. Dot blobs is going to be blobs, and dot trees, I don't know, like what trees does this have? So this might return either a tree or an object. So we do that here. Yeah, we can return tree. If it's a directory, we'll return a tree. The problem is, like for nested directories, we come in and we see if it's a directory. If it's not a directory, we'll just take the file, return the blob from this. And if it's the directory, we go through the directories, we go through the files in directory, and maybe one of them is not a file. So if it's a directory, we need to do something to see that this might have some other directories as well inside this directory. We'll be back in 2 minutes. We were trying to add a tree, right? So maybe I think this should work, but for nested directories, right? That's the problem. So how do we are not storing the trees anyway. So we have these trees, but so one tree can point to other tree, right? That's where should we do that? So this will return a blob. This is fine, and we are pointing all the blobs. That is also fine. I think okay, we are calling it recursively. Again, that goes in if it's a directory, it's going to add everything, and this might return a this. Okay, this might not return a blob, but it's an object. We don't know if it's going to return a tree or object, but that's the thing. So then how do we know if what we should do here? We have a list of blobs. Maybe we try to get all the objects, I would say. Can I do tree? I would try to open the objects here. I would return the object, I would say. Not return. So I have an array list of, so this is going to be tree. I have a hash of, I don't need to build a tree explicitly. I just need to return, if it's a directory, I just need to add all the blobs and trees to the objects. And then return that. So if it's a directory, because it's a directory, I will say I'm going to create a tree, and for objects, next or items, I get an object. So I could say tree dot, I need to check the type. If the type of object, type of struct. We need to check the type of struct in comp time. I need to actually check if it's a struct. I mean, if it's my struct, right? I think better way would be, so what we're doing is we're trying to go through the objects which we stored. We're going to try to create a tree like this, but we need to initialize that as well, I guess. We need a, we need an allocator here. That's fine. Let's say tree dot init. we check if it's maybe if I so if I remove this tree, it's okay. I have to create the tree. So I have an object here. So for the trees, right? What do I need to send for the tree? So I know the list of blobs that I have. So basically, I need to populate the tree dot blobs and trees by checking the type of an object. So if object, what is an object? It might be a blob or a tree. Check if an item is of type struct construct. I just want to see if I can do that. That's fine, but this is not what I want. Create array list with multiple types. I don't know if we can do that. Okay, it has to be an union with this. We'll just add that here. Object, and it's a blob, it's a blob. Tree is a tree. And I'll create an array list with object. So now, how do I know? I iterate through this object. Um, hmm. We get its own type. Let's get it type. Okay. So let's try printing the type. How do I see? What I want to see is type of object. Type of. It is for status. What is it for add? A blob. Where did I do that? Shouldn't be where, I guess. Yeah, so we cannot return this. How do I return? Can I return an object? It dot add dot object. Function will declared here. Yeah, we're returning something else, but we need to return an object. This is a union, so that's not possible. So if I return a blob, but the problem is I need common structs. Yeah. There's a function. Maybe we can create an object which is a struct and can have a public function. Um, Maybe we'll have a type function, not a function, but the type. And just say the type is going to be object type, and what the object is going to be either blob or tree. Tree is going to be tree. I think that is fine because when we are returning this, we don't return a blob, but wait, let's see how they are returning this. Yeah, we return an object. Just have to add that as well. Return an object here with dot type is going to be blob, and blob tree is going to be empty here. Then it should be smaller to this. Then return, leave this as is, and we append this. And now we can go through the items. If object dot type equals blob, do something else, do something. Just say t dot blobs dot append allocator, and item is going to be object. T dot trees. The trees are again a list of uh, the trees. We can just we need to write and then append. Write in the sense we need to write to the path of the. What I mean by that is that we have to create a tree first, then only we can append the hash of the tree. And how are we doing that here? Maybe we are creating. Okay, we get all the objects, and how is the tree hash calculated? So we just create a file like this. So if it's a tree, um, first let's for each element in the object, actually we're going to have a strings and say, I just want to append it dynamically. Is that possible? I want to do it. Okay. Maybe I'll just do this. The content is going to be the tree content string. Raw tree content is going to be, what I want to do is, so for each object we're going to say raw tree content dot, and I do this. Plus is equals to the type of this and the hash of the object. So because it's an object, you can go inside this, see the type, see the blob, and it has a hash. Okay. For now, let's do that. And the tree content is going to be just do that. Uh, this is going to be object dot type. I don't know what that is. Union to string. We have an union here. Union to string. Okay, we have to write it manually, I guess. Okay, let's do that in utils. Um, Pick an object which should return a string. Well, I think we have to import that here. Yeah. So how do you do that? I think we will just return switch of this object. If it's of type, I think it's object.type. It's of type tree. I'll just return tree. Of type blob, I'll just return blob. And here, the raw tree content, I think I can just say utils dot string object. The next one is the hash. The hash here. I think it's object dot blob, I guess. I do this like this, and here I just make it as 3. Don't know if we need this, but maybe we can write the raw string now. I think it should be a new line. Let's just print. Let's say raw. I think it should be raw string free content. Sure. On with blob. So this should return an object that we are appending that here, right? Isn't that fine? 67, it's here. We just append the object here, and the add is trying to we see that we can just say utils dot object to string and object equals. I think it should be like this, also like this, because you're going to do std dot n dot equal. It's going to be u8. In tree we don't have a hash. '91. Oh, I think it's object type. How do you do this? I'm not sure. Make this pub. We do this because we want to um, call this as blob. Wait, can we just make it a string? It's confusing here. I mean, that's unneeded complexity. That's what I'm saying. It's an object with a blob. We're returning any object anyway. 91. I think here we need to return a tree. It's defined. This is undefined for now. Okay, utils. I don't think we need to can just say object dot type now. I think there's one error. Yeah. Switch on type. People using this. So we have 79. If object, I think this should just be object dot type. Yeah, we need to return something. Let's return a tree. We need to return an object. Even this, we need a type blob and tree. Let's build it. Type git add. Yeah, I think we ignored that because we don't need it. Go to git add. Yeah, I think this is good. So my question is, if we have, so this is for src, we do that here. Okay, there is a loop, but fine, we'll come back to that. Let's zig out. Let's try zig out. Um, the bin is again okay. Let's try src utils. So we need another tree. I think that's fine because we didn't get a tree anywhere. What I mean by that is we need to return a tree. The blob is undefined, but we need to build a tree object. So what does a tree have here? So let's, yeah, it's here. We have a hash of the tree that we need to do actually, but we need to hash everything here. We need to move that to another function. Let's open hash.zig, import this, import the sha1 as well. Now we need to hash this and return. So basically I just want to have a public function hash which takes in the content and it returns, do we have try here? It returns this. Fine. So let's the buffer is going to be the content, and I think we can just return this. I need to do hash.zig and I need to say hash utils.hash the content which is buff, I guess. Does it still work? This is add, right? It is. Oh yeah. I need to during add. I think we can comment it for now. Um, 40. Okay, I think but we are trying this here. Does this cause an error? Hash out is 20. With the content it's going to be um, the buffer, which is U8. I think that's fine because hash string, I think we can just pick it out. How do we do that? Ah, okay, we just need it there. It works. Now, when we're building an object, this type is going to be tree, and the tree is going to have something else. The tree is going to have a hash, which we're going to say hash string is going to be try hash utils dot hash. The content is going to be raw tree content. And then I'm going to put the hash as hash string. With this, I think we have the hash is done. Blobs. I don't know if we have any blobs here. Um, I think we need to write this first to um, we need to write this like this. So this is a new path, the hash string. We try to open the path. Wait, what are we sending to hash and store? Sending the path. So the thing is, we create this tree content and then we hash it. So the problem is we don't see any tree right now here because it's all blob. But the reason I think is we're not storing anything in the tree, like object which we are appending it. The recursive call is not sending any tree. That's the problem. So when we send this, I think it should work. But if we send this, we're going to check. We are going to check the hash of the tree and the type. So actually, let's just send this. The blobs are undefined. The dot trees are undefined. Does this even work? Doesn't. But still returning the content. When the tree type as tree. Oh, then why doesn't it work? Type is an object. I think it's more like object dot type. Nice. I think it should be s or string. But yeah, we get a tree type. We put it into the objects. We check if the object or type is blob or tree. The thing is, when we are printing the hash, right? It should have sent this. Let's do this. Yeah, we're getting the blob and tree type. Okay, can I? Let's do iterate. realistic for list dot items item and index. Um, for list dot items and 0 dx. Let's just print the let's also print the idx. It's not going into that, but why is it happening? That's the problem. Okay, it's going into. Okay, we are writing to this. I think that works. Okay, but why are we not? Oh, okay, we are not appending to it. So is that the reason? Is that the reason? String and append zip. We are trying to append this. Okay. Now do dot append. Okay, this is a constant. Wait, is that the only way? Hmm. We need to allocate that raw tree content. And then when we are appending it, we can uh, try appending this to raw tree content. Append. No buffer. Okay, I think it might have changed. That doesn't work. Not to an array list. I just want to append to a string. I think it's concatenate, right? I think it's plus plus. Or is it do this equals this plus plus this? Comp time value is okay. You need to do this during. I think then we'll need an allocator. cd standard mem dot. Okay. Um, we'll use raw tree content and this. So we have this combined, and we will try to do add that too. This is, I think, after adding that, you can just say yeah, we get it. Awesome, right? If I remove the index, don't need the capture, and I don't need to print this. I need to print the last. You see, we are able to write this to the tree, and let's see format of it tree. So for now, I think we just need to write this to the tree, and let's see what is there in git cat file. I think just pick this, of this, put this. So you see the tree. This is the format of the tree, and it says this is in this tree. The parent is this tree. What is BD here? I think it's a hash of this, right? The hash of this, but this is a tree hash. This is tree. I'm going to see if it's recording. Let's see if so. This is, I think, uh, format of the tree. So this is a source tree, right? So if you see this tree, there's a tree hash, right? You see this tree. That is what exactly we have here. But we have to add the file names and all. But still, actually, let's add a file name. Or do we need that? Because in this blob, right? We need to have a path. Let's add a path actually. Or can we add the name of this? This is a name. Let's check the new path. Okay, new path is this hashed one, right? Let's check the old path. I think we can just put path here. And here is for the path, I'll just put the path. And here as well to the tree. Let's conservate. And the path is going to be path. When printing as well, I'll just print it at the end. Just for a second, I'll just put it here. Check dot blob dot path. But it's tree dot path. Okay. Really, I want to remove the this. Yeah, I think it works. We have to write actually. We have to actually write this to. For um, I think just we can just remove this thing, I guess. What do you say? The path. We just need the current path. Does the file have any path? Get path of file in zig. I think for now let it be. It's fine. So let's write this to. Let's hash the raw. We have hashed the raw tree content, and we need to first store this. So what do we need to do is that we need to store raw tree content at object slash hash string. We need to first store that, then create a tree object with. My doubt is this is a hash of all this, but as I've seen before, what is this? So if we take a commit, okay, that's a commit, I think, right? Yeah, that's a commit. Okay, that's fine then. So a commit is from a tree. You can catch the tree and see what is there in that. This the tree is actually the working file of the root, everything, right? When you commit, you put the root tree, and there's a parent to that. So when you commit, you link the parent. That's great. So right now we store the raw content at the hash string. I think how do you know how do we know which is a working tree? How does it know what's the working tree? Um so if I do git work tree, I guess list. Hmm. What is a work tree? Okay, there may be multiple working trees. So yeah, I think this is fine. And so after storing the tree, where do we commit, right? How do we know that this is the tree we are referring to? Okay, I think that goes in the file. So if you take the root directory, I think that itself is a tree. So okay, let's first store this. So I'll take this from this. Go here and I'll say object slash string store it, and then we will return the tree. And we just do objects here. It's, I think, object. This is compiled. Yeah. So, did we write anything to Sigit? So let's remove all of them, and let's do slash utils. Let's create a file inside utils so that I don't know, test utils dot save. Now if I do utils and if I do refresh, an empty file, I'm getting all empty files here. Okay, aren't we writing that to when it's a directory? Okay, we create a file, we're not writing to it. But we have to write to it. New path. But aren't we writing to it? To write this, right? I think it's a new path. Not this, but we were trying to store that somewhere. I think I removed the write function somewhere. Not able to see where. This gives us a file. I'll write the buffer here. Does this work? Doesn't work. But we did write to file in zip. We did write to it, I remember that, but how did we write that previously? Hash and store, it opens a file and it creates a file, but we don't write to it. Try to read from that, write to the buffer. Okay, that would mean that's the data. I think we have to write the buff, not the buffer. We have to see which one we have opened here. Let's we open a file. We need to open a file. So this is for which path is this? That's the point. We have to do this for we're going to create it for this. So then we create a file and then we try to open it, I guess. We try to create open the open path. Um, This is confusing. Okay, I think. Wait, did we just get a read-only mode? It's still not writing. I think the reason might be that doing something wrong somewhere. I want to quickly finish this. Um, don't want this error to hang for so long. So we are storing this at this position. This what do you say? Yeah. Aren't we writing this to get the hash, the path, but we haven't written the actual data, which is the at this path, and we store that in buff. We try to hash the buff, but we are not writing the buff. Okay, let's try to write it. Okay. Try to write it and then. Okay, I think what's happening is that we need to delete this. Run this. Yeah, we get content here. And we need to do the same here. So we create the file and then we have to, I think it's like this. And we need to write the raw the content, I guess. I'm not wrong. I can just delete this. Yeah, we have these trees, right? So this is one tree, we have this another tree. You can see, if you see this, this is our src, sorry, the utils folder. So we have this blob.zip files, and we have this test utils folder, and the trees hash is this. And if you go inside that file, which is this 1 and 7, inside test utils, we have this test utils.zip. So that is great. But this doesn't make sense until we do a commit, right? So I think git add works. Git add works now. So we just need to see how commit works. So when we are doing a commit, right, we take, so if you show me this tree now, I'll be sure that so this is the hash of the SS. So similarly, we need the roots. We need the root of the folders tree, and even if you don't add anything, whenever you add, we'll just update that tree, I guess. But how do you get the root of root tree? When you're doing a git status, even you can see, what all we have added, which is correct. And just thinking, like, because we are going to do a commit, we have the blobs with us, we have the tree, but we don't know where they exist. That's the problem. If right now I do commit, I think what I need to do is I need to check if they exist or not, like these files, if they exist, then I add it to the working tree. I mean, I add it to the commit. So as we have seen before, just open a new tab. Go back, git log, get this commit. I think we did the cat file. So this is a commit, right? So this points to a tree. This tree is the working tree of the entire thing. So we need to get the working tree of not some folder, but the root folder. Right now we don't have that here. So when we do a git init, should we create one? Or maybe I think when we do this git add, right? We need to create one for the working tree as well. When we are going through this, it's a directory like everything. Maybe we need to add a check which will get the working tree. Working tree in the sense it's just a root tree, right? Is the audio fine? Yeah. I guess so when we are doing add, let's see how git stores. It's too many. Delete everything. How gets how does git get the working tree hash when committing? Yeah. It's we do this. So they say that it takes a top level tree object. So how do you get the top level tree object? Do you store that somewhere? How does you get the top level tree object? Yeah, I think head is okay. I think here as well. If I go into git head, just bd. Let's go to bd 89. Okay, let's take this commit. Not commit, it's a working tree, I guess. Oh yeah, it's a working tree. So working tree is a commit. It makes sense. Right. So if for example in this we have a head here. Okay, it's only when you commit that happens because this might be the head. Create a commit, you put in the okay. So when we are adding it, what happens? We okay. I think I see what I'm doing now. So when we are adding, we don't want to create a tree and all. We just need to somehow create the files, and only when committing is that you create a tree and you do this things raw tree commit. That's what I am guessing. So if you take a tree, right, the tree is done as well, I would say. So we'll take a commit. Yeah. So if you take a commit, right, that Even the add, not just a comment. When you do an add, what it does is that it only moves the files from non-staging to the staging area, which means uh, only the files which you want to commit. So if I go here, does that stores that somewhere in index? Yeah, I think it has an index. If I do git status, yeah. So let's say if I modify something, add a new line here. So it has modified this. How does it store here? Okay, it opens the index. I do dot get slash index. So dot get slash index contents. Get show index. I think it stores an index file. You can see here. Yeah, I think I get the point. The index is what we needed until now. Um, so what we were doing was we were updating the index, we're not creating the tree, and that helps when we write a commit. So when you run git add, the files from your working directory are hashed and stored as objects in the index, leading them to be stage changes. When you run git commit, the stage changes as stored in the index are used to create that new commit. So when you add, are the files created stored as objects in the index? Yeah. So here, yeah, as well, there's no index here. So if I go to git, there's no index. There's a head. There's no index here. So when we do git add, it has to create. It creates an index. For example, in this case, right? If I do git add make file, and if I go inside and see the index, just paste that here as well. It says this is the only file which has been added, right? Nothing else is in the stage. And I do this. Is there anything other than stage? Okay, that's the no stage. Oh, that makes sense because so this is what we want to do. We want to create an index file, and then we want to store the working condition of, I mean, working. This is the working directory, you would say. So when you do git add, it creates that. So when we do git add, we want to create an where are we creating it? We want to create that in zig object slash index actually, and in the index what we want to write, okay, it's we create the index file and we have all the hashes. I don't know if it's a tree, but what happens if I say git add src? If I say that, it says these files. It just says this file. It doesn't say it's all a blob. I think it's just not uh, a tree. It doesn't show any tree anyway. So I guess when you commit it, it creates a tree and then writes all this blob there. I think that's what it does. So now if does it create the object? Yeah, it does create it does create that. I think what we are doing is fine. It's absolutely fine, but the only thing is that we need to write this uh, final data to index as we add. Like when we do an add command, we need to keep track of what all are added, just added, not anything else. So I think this is fine. So if you do this git status, right, we know what is added and we know what is not added. So let's see if I go to hash.zig, add a new line, add a comment, and now if I do git status here, let's see if hash.zig is not staged because that is not found in the working tree. This is not the hash, at least. I think that's great because we just now need to track the index as we do an add. So whenever we do an hash and store here, we need to append this to the index file. So let's say an index. So we say this, we get the blob. The path is going to be dot cgit slash index. We're going to do the same here. What is the content going to be? That's what we have to decide. And I think can we write append to file and save? We just need to append to it, or I think for now, I think it should do the yeah, we need to get the size and seek to that. So we'll just try to get the stat. We'll just seek to that. Yeah. And then we try to get the writer. Then just say writer dot whatever this is. Yeah, what do we want to append to that? So for now, we will let's assume that we can only add, we cannot unstage it. So there's no unstaging here. Let's just assume that. So what are we going to append? That's the thing. So we need this format, right? Whatever we were following in the tree. So this git follow the tree thing. Add file. So yeah, it's the same thing most. Okay, it's different. Everything is a blob here. So what I'm going to do is I'm just going to append the hash and the path. So it's going to be blob dot hash and blob dot path. So this index. So for now, I'll just remove this. I'll do git status. Does this take? The buffer? What is the buffer here? Hmm. It needs a buffer. What is the buffer? That's the point. Oh, is it like, where do we want to write it? So let's say var buffer is does this work? Okay. What does this do for? So can I do debug dot print? No. No. Wait, how do you even append to file? Okay, maybe we can just seek the file and then write it. When we do that here, is this we just need to concatenate these true strings. How do we do that? We're writing raw tree content here, but here we just want to append that to the file itself directly. How do we do the file formatting thing? Const content is this locate no, I guess we put the hash and then we put the path here and then we write the content. So anything is not staged. If I try to stage something, let's say make file, I do the status, I think make file is there, but here I think there's an index created and it writes the hash of that. So this is fine, this is great. We have the index as well, so this is a working tree which so when we create the commit, right, you hash the index, I guess. Isn't that what's happening? So this is the commit. Okay, it's a hash of this, but this is there. This is there as a file in Git objects. And this is the actual tree content which we do have. So when you commit, you have to create a commit hash from this content, and you create this tree hash from the index, I guess. Is it from the index? Because if it's not from the index, where does the for the initial commit, where does the bit take the tree hash from? Which contents of the staging area or index? Yeah, I think it's this hash. I guess for the non-initial, if it's not index, yeah. So the new commit object then stores a pointer to this newly generated tree object. Newly generated tree object, yeah, index, as well as a pointer from the parent commit getting historical link. Yeah, yeah. So I think that's what the commit does, right? So if you don't add anything, the commit is not going to change. I can't commit duplicate. There are no duplicate commits, I guess. So now the add is working as required. Now is what the commit is going to do. The commit is going to take this, create a hash out of this. Actually, let's do that. So let's go to main.zig. I think it's git.zig. So let's try this. If it's a commit, then I have to call this commit. So commit takes a message, the commit message, right? So you have to do that as well here. Wait, okay. I think it's a set commit. The message is going to be from the third argument, and this is the message. We need to create a commit.zig, and this is going to have a public function commit with the message. Let's say this doesn't return anything. For now, let's keep it like this. So here I would just say let's just say git commit here. The git add has a path and an allocator. So I think we'll need an allocator here as well. I'll just do this. history.num.allocator. Let's just take that from the main. If I see the add.zig, I think fine. The allocator is the same, but we're not using that for now. We'll just put it in the underscore. So I guess I'm doing the initial thing correct. If it's commit, we're going to take the third argument, which is a message, and then put it in the commit. So now the commit here, right? We have added the make file. So we could just see this index. So let's see what we're going to do. So we're going to read the index. It's execute slash index, hash it, hash the file, hash the contents. So that's the key hash, I guess. Create commit content. So I think it's in the form like this. Tree hash. What else? The parent. There are no parents, but parent tree. So the author committer, I think that's fine. And then the message. Right? Hash the above contents. Commit hash. Create. I think it's dot secret slash object slash commit hash and write the above content to it. I think if you do this right, we can. My doubt is like, how do we get the initial commit? Where is that stored? How does get log work? So how does I get the commit? How does get list of commits? Yeah, I know that, but I just want to see the commits. How does it internally, I guess? Okay. Which commits? Okay. When you run git log. Okay. Now it takes head, like at which point the commit is at. So here, if you see the head refers to this, but must be some head. Yeah, BD is the fetch head, origin head. Let's do fetch head. Write the commit hash to fetch head. It's dot git slash fetch head. This, that's fine. So whenever we want to get a list of commits, we can just take the commit from the fetch head and then go through the parent commits, right? So when you do the secondary commit, you do the similar thing. For the parent tree, right? You use the fetch head and you update the fetch head to the current commit. If that works. Yeah, I think that works. So let's see. I might need some help from the add.sig utilities. So first we're going to read from index. So that is going to happen like how we did here. We need this. We just need to read the index. I think it's here. We'll open the file. The path is going to be .zigate slash index, and we'll write it to a buffer. I think I need to move these things into an utility, and then we hash this. We hash this. We get the hash. Let me see. Is it similar to writing hash and store? Because I'm not sure if we actually need this thing. It's the index. I think we don't need this. Now we'll need this. It's just get slash index. I think I need to index path going to be this slash index path index path and index path, and we haven't written the hash string there. So to the index, we're going to read the index, and then we're going to hash the contents. Yeah, we're going to read the now we hash content. We want to create a commit content and write it to um, um, I think we have read the z index. We have hashed the index, so this is the index p hash. So now we need to create a commit content. Let's put this on hold, and we just need to do that in the same way we did this. We have a raw tree content. In this case, it's commit content, and then I can do this maybe. So I try to commit content, and then what I'm going to write first is the tree, which is going to be the index tree hash. And then I'm going to put a new line here. So the next thing we're going to write is the parent tree. So for first index, let's say for the first commit, right? There's no parent tree. We have to see if there is a parent tree. Now I'll say fetch head path, right? I don't want to do this here. If the file is not found, I'm going to do something. If the file is found, okay, if just the file is not found, maybe, okay, if the file is not found, then I don't want to write the parent string there to the commit message, not the commit message, to the commit tree or the commit content. Maybe we can say where does fetch head exist false. Now let's say true. Let's set that to false here, right? And I can check just if does fetch head exist. How do we read this? I think I have the F here. It's not the index path, it's a fetch head path. So I say it doesn't exist here. And then this is return actually. So if the fetch head returns something, I want to say parent tree. To that I just need to read from the file, which I did here. Just read some utility here. Read file. Just read my file. That's what I want to say. So I'll open the file. I'll close. I'll move this here, including. I'll just copy this CWD. Okay, and the allocator as well. So now the buffer is going to be read file from the index path allocator. Comment this for now, and then let's just format this. So we're reading the file, we get the buffer. Similarly, we do that here. Parent tree hash. So this is the parent tree hash that I get from this file, if it exists. Right? And I'll just say parent tree hash. And now if it doesn't exist, we don't need to move anything, I guess. So we need to create okay, I need to write the commit content, I mean the message to the content. Just say commit message. Where is it? Okay. So I guess we have this commit content which we can print for now. Commit content. So now if I do git status, okay. Should I do an else? I'm doing that. It's for 7. You do this, and when you read the file, just do this, try. I don't know what's the problem here. We might try function with non-void return type implicitly returns. Okay, I'm not returning the bug. You wait. Where is this? Wait. think it probably might be somewhere here. But it's a problem not understanding that. This is a compile time error. What? Maybe this needs to return non-void thing or something. Because expected 2 plus struct argument found this. Okay, is it for um, this thing? Um, okay. So what if I do this? That's still getting that. Not seeing any. Ah, okay. I think it's the debug. But what's the problem with this? If I don't do this, will it work? Yeah. Commit content should be you wait, right? Is it debug.print only? Yeah. I think that's a typical. Okay, status works. If I do commit the message, just message. Actually, I would take the entire string, but so now it says tree and this thing. Now commit message. That is fine. Now I think we need to create to hash the above contents again. So we need to hash it. Hash the commit content. Yep. Hashed commit content. We try to hash the commit content here. And let's see, hash commit content. Yeah, we get that. And we're going to create this. So here we're going to say hashed commit content. In the new path, again, we're going to say if it exists or not. I think it's more like this, where we are writing to the file. So if it is not found, it creates this, but if it's found, then what we're going to do when you're adding them? It just creates a file. Uh, but these things I think we need to do outside of this. But we need the F for that. Let's say this const F is dot read file. The path is going to be zigit dot zigit slash index. The buffer is going to be, I don't know what that is. Um, I just think can we write to this? Yeah. So then maybe we can just give this path is this. Just rename everything. It's fine now. Now we just need to do the same thing here, which is we need to what do you say? We have hashed it. We need to create that file. Um, we'll create this. We'll create the new path, or else we'll create the new path. So, which is the hash. I mean, we need to even write to that. If we say this, cd.fs.cwt, I guess. So this comes with new path, and then the buffer is this. We try to read into the buffer, or should we write it to it? So this is going to be commit hashed commit content. What do you need buffer? Yeah, we don't need to read that. So we create that um, this path, and we actually write the commit content. So we have written that, and we have the hash of this commit, um, which we are going to put it as the working tree, I guess. So we have created that and write the commit hash to the fetch head. What does the fetch head have? Okay, fetch it is not what we want, but I think just to head. Okay, I think what is happening is you go here, and if you see the head, it points to head's main, right? And ref head's main. This is okay. It's awesome, right? So that's what we want to do here again. So we don't want to do fetch head. We actually want to do the head, and the head will contain the let's say for now branch. Um, the current working branch or the default working branch. It's going to be a string again, which is main. So so what we're doing now is that we fetch head exist. I think it should be more like fetch head path. Yeah. So if that exists, we write the parent path. But now what we want to do is we want to not write that, because how Git works is, I mean, for now I think I'll not create that. I'll just read it, and whatever whatever we have, right? I'm not going to have the refs or anything because for us that doesn't make sense. So I'll just put everything in head. Instead of the ref, I'm going to put the commit, the last commit of this branch. So when branches get involved, I think then that helps. Which branch is going to have the latest commit? I think that's very cool. So I think how does that work? So right now we are, I don't know if we have tested this, even if this works, but we are creating this hash object. We are storing the commit there with all the contents. Let's actually test that. And after that, we are trying to open the new path. We are going to write to it. Oh, that's fine. Let's actually commit this. Okay. Execute index. Yeah. Let's do the commit. Not open for writing. I think wait, what? 69. So this is not open for writing. So we have written, I guess. Now if I go inside index, it shows this. Okay. And B8, I think it shows this tree, the 7EC. But wait, what is 7EC? So we have written the commit content, and that has, first thing we have written to it is a tree, which is the index tree hash, which is the hash of the index path. Okay, but I think we need to have this file as well. We need to first index, hash the index. We are doing that here. Index tree hash. Okay, I think we have not written that to the index path. Just write path. To this path, I'm going to write this content with this allocator. Void, and this is going to be the path. The path. We don't need the allocator here. So now I can just say write path to the new path. Content is going to be the commit content. And just remove this. And before that, I also need to write to the index, which is index path. And wait, not the index path. It's actually index buffer. Just keep it index. So it's, I think it's, yeah, object slash index hash. What is index hash? Yeah. So we need to write that into index buffer. Now the index path, I think it's index tree path, right? So for to that I'm going to write the index contents to a read file. Okay, I can just have the buffer. Now if I do a comment, remove this comment, where would be it? I have the 7EC. Inside that I have the contents of the index. Right. This is the working status of the tree, and I have this tree here. But I think after committing, the index should be gone again. I need to truncate the index. So remove all contents inside file, because that's how um, I can do this and create a file. So I can just do this. So the index tree path, so the index path, I'll just truncate it. See, I think now that's fine because we have the commit, but we don't have the head here. We have to have a head which points to this commit, which is B83. Right? Wait, we don't use that. The fetch head path. Yeah, we only use it for writing the parent. So if so else we'll create the folder once, and inside, I think for now I'll just put this fetch head path, and so now we are creating this path which is the head, and inside that what we're going to write, it's the commit message of the topmost commit. So finally I'll just write to the fetch head path the hash of the commit, no, the hash of the commit content. Is that's it. If I do status, so I think we have to update status as well in order to see if this exists. So this does exist, but we have to see if it's in the index file. Like in the index, we have this what do you say, the file, but how do we know that if it's staged or not? So maybe we have to get the head, and maybe we just have to get the index here. Wait, do we need to create the index? Because let's assume you're not deleting the files, then I don't know if it works. I guess status is fine for now. So the index we commit, if we see the index here, it only has unstaged and unstaged ones, right? That's fine. So, and if I see this page, you can see these all are staged. Is it staged or? Yeah, it should be staged. Are the files inside commit staged? Yeah, but so if you see this commit, right, which is B83, it shows a tree. The tree is the working structure of what the hash was. If I go to EA, it again comes out. So now if I go to make file, right, and if I remove the arcs here, and if I try to say this is fine, if I come here and I say git status, now it shows that the makefile is not staged. And if I say add makefile, okay, there's a bug, and add zip 132 f. I think I need to add a mode. Yeah, so if I now I add the makefile and I say git status, now this exists. And if I even do the commit, just commit to, it commits. If I come back, see the zgit folder. So now I see the index. Yeah, it has been cleared, but I see the head which is pointing to B4EE, and that we see the commit now, which is now the current commit which I did, just commit to, and the tree it's CF6, and here the hash of the files. It's an added make file. The hash of it starts with F6. We go to F6. See if this doesn't have the args. Right? So this is the current working directory. So this doesn't have the args, and but if you see the previous commit, right? For example, I think B83, which moves to C7EC3, and then this points to the 6E, which is this. This has the arcs. If you see, these are the different snapshots which we are storing. There's much optimization which can be done here, but I think this is the actual functionality which we were looking for. And also the head points to the latest commit, which is B4EE. So this is the file, and this points to the tree. So this tree points to CF6, and this is the actual working tree before we truncated the index. So now when we do git status, what do we need to do? Where does git status pick info from? It picks from the index, I guess. Yeah, I think for now we'll just show the git status as is. So now the important thing is the git log to see, or so now I know that there are commits like this, right? But I want to see what all commits I made, so I need a log command. For the commit, I think this is fine because it creates a commit. We can even go with branches, but that might take some time, I guess, because we need to move this to refs, the one which was pointing. But so right now we are not changing anything in the working directory. We are just storing these files in a different format. Right? And if I do status now, the makefile has been staged. Did we commit it? I think we have committed it. That's the reason it is exists. And wait, how the oh yeah, because the hash exists in this tree, it shows that it's existing here. And if let's say I add, I think that's fine. This works because we have tried that. Now if I want to have the log command, let's try to do that a bit quickly because it's like a linked list now. And if I add the log here, I don't need anything. I just need the z log. This is a git. We need to add a log file, log.sing. Log. I think this should be enough. And we try to import that here. We'll just call that as just keep it like this. We have the git log. I think yeah, this is good. So now the first thing we're going to do with git log is that read.git git slash head, because that has a actual commit. Then read.zigit slash object slash, sorry for that, head hash, let's say. I'll call this as head hash. And from this, I have to pass, recursively pass this and show that these are the trees, right? I take the commit of tree out of this C4673, EF673, and I go here. This is a commit. Wait, yeah. So this is a commit. This has no parent commits. That's a thing. So we actually this should have had the parent commit. Yeah, this should have had the parent commit. So maybe now, right now we are not, when we have the head, right? We're not writing the head. Head path is git slash head. Yeah. So actually do this. I think we have to do this from the start. We don't have a head. The index is empty. With status. So if it's file not found, then okay. If fetch head exists, when we try to read the file, get the parent, or else we create the file and we don't write anything to the file. We just create it. Maybe we need to write um, fetch head path. Yeah, so we need to write the hashed commit content to that. So this works, but why is it not writing the parent? Is that if I do git add make file, this is the commit. So head is pointing to F7, which is CF again. This is the content. Yeah, that is fine. Now if I go to make file, if I just add such a build.zig as well now, and I do commit to, so it points to 5FC. Yeah, that's a parent. Parent is F7E0, which is this, and the tree is 1D. 1D has this D07, but I think we need to add the current for, you know, I think we need to add the reason I'm seeing this is because so this tree, right, 1D4, this should have had the makefile as well. Is that okay? I don't think so. This is only the files which I've changed, so I think yeah, this is fine. Because this tree has also the parent. So yeah, that's fine. Now we go to the log.zig. Let's just read the file. Just copy this. I have to create a function. I mean the utility, but I'll go to, I just have to read the file. Let's say head contents is read the file to zigit/help. Yeah, I think we need to add the allocator. Yeah, so we have the head content, and that is actually the hash. So we need to go inside again the let's say this as var. We have another var is end of commit tree. The file is not end of the commit tree. We're going to loop through it. We have the head content, yeah, which is the Yeah, we can, that's fine. So we can just loop through this now. We read the file on f is read the file at path. Um, this is going to be something like this. So what is index buffer? Yeah, there should be buffer. So it's these objects and the content, right? And we try to read this path. We read, okay, it's just we try to read from this hash, and then in that hash I think we have this commit object. We get the file contents there. Let's just put it for true right now and say keyword.print f. Okay, so the thing I need is the we will we we actually will display it like this, right? And then we might need to add how do split strings. This going on. Yeah, so we see that we actually get the content from the head. We just need to take this. We have to read line by line or something. Okay, let's split it by new lines. Let's see. F. Is to dot next. I think I have to do the loop, but is it not possible to get? Okay, the first. Just put as any. Okay, it needs found this. Don't. We get an iterator, but we're not able to. This is okay. This is for split any, right? So did we get const? Ah, okay. See. Um, we want to do the first one. Let's see if we get that. Yeah, we get the first line, and const tree line is it dot first. We have to do a lot of error checkings and error checks, but because it's going to be a file, this thing, if tree line dot len is equals to 2, we want to do something. Tree hash head content is going to be tree line of 1. Const parent line is going to be a t dot next. If parent line, if parent dot len is not equals to 2, I mean if it's equals to 2, then I want to say, I mean if it's not equals to 2, I want to say this is true. Right? So if I get the tree line, I update the head content, the parent. I don't need the parent, I just need the, but parent, it's just to find the end of the commit tree. So now what do? We have the head content. We just need to just this compile. Head content should be a variable. Tree line of 1. I think it should be something like tree line should be with this by space, and this is just pr dot next, I guess. It doesn't need to be a const, I guess. So you're trying to, yeah, I mean, people are saying that this is a problem as well, because this is giving me a const iterator when the const of this, but I don't want that. I want immutability. I guess we just need to assign it to some other variable, like var h is this, head content is h. No, this again throws that. We just need to say that head content is this. And why do we even need to check the head content? Because I think this is better. but I don't know. I think again this is a zig problem because what I want to do is I'm splitting the content by new line, and then I'm getting the tree line as a constant int, constant u8, and then I'm just checking the length of this. It will be more than. Okay, let's actually just do this. Yeah, so what the length is going to be here. The length, yeah, it's not two, not two. We need to again split it. So I'm going to again split this like this. Again, I'm going to do PR. Oh yeah, so I need to do this first. So I think I can take the buffer, and if I convert this to string, I think I have the buffer. I just have to split it in the. What if I take that, and how does this work? Yeah, so the tr. So we are just seeing, but okay, we need the here it's taking the entire buffer. We just need the first line. If it takes the entire buffer, then okay, maybe what I can do is I can take the first, um, and then for this, I can say tree line dot next. Yes. Okay, this is. I will do it dot next, right? And then the tree line is going to be the rest. Does this work? Hmm. Okay, I have to. I think I just need the first here, but when we split this again, then we need the rest. So the first, and then we split this. Let's try this. Yeah, I do tria dot rest. Do I get anything? I can do this tr dot next. Wait, what? Tr should be where? Yeah, we get it. Tr dot rest is but this is a const. Again, that's the problem. Is maybe we can just say the tr here is, what is this, split iterator, I guess. Split iterator. Right, so I'll just say tr is this, and that it's not the head content, it's tr dot rest. So if tr is undefined, and path is going to be this, but here it's going to be head content, else path is going to be this with tr dot rest. Not going to throw some, okay, it's iterator. Um, so how do we solve this? Okay, I think it's, should we do comp time is this, delimiter is this. So if we can do, how do we check if it's, if tr dot, let's say if tr, how do we check the type? Tr, okay, but that's the type. Maybe we can do this. Maybe we can just say if head content std.name dot equal content dot length, what is it? It's usize. Head content dot length. Is there a greater less than 1? $32. 8. Is this right? Because what we're trying to do is we're going to print this onto this, but expected type is this found U8. I guess this hacky kind of way doesn't work. Maybe we will need to. I think this problem still exists. std.debug.print that it's a compile time error, so you're not able to see this. But they're expecting a const here. This is also a const. But I don't think that's the best way to do this. So we are going to read the head content first. We're going to read the file. We're going to split that by new line, and we're going to take the first line. We're going to split that into multiple. We're going to skip the next, and then we'll just take the rest, which is the ID hash of the tree. And this, I'm not able to put this to another variable. That's quite irritating. Set iterator.rest to u8. I think it's zig, right? Yeah, skip hello. Const immutable rest. Const. Okay, we can do allocator.dupe. Const hash is tr.rest. Allocator.dupe hash u8. Const mutable hash is this. Yeah, finally we get this. And now we say head content is mutable hash. And we have to also see this. But how do you know if it's end of the commit tree? That's the question. We are skipping the next here. We're taking the first. Const parent line will be next. So again, the parent line. We're going to skip the parent line and take the. No, we don't need to split it. I think we just taking this is fine. So if c.mem dot equal u8 parent line, if it's this, I think is end of commit tree is true. Let's see the compiler is fine. So this is great, but we have to make sure if you're going through all the comments. So here we have the mutable hash. We're reading the file. We need the file content. We'll just print that. Um, okay, okay. I'm getting hang of the errors. Yeah, but I think we have to go to the parent, do we? Yeah, we have to go to the parent actually, not to the tree. So we split this, we take the tree line. um, we actually want the parent line, and if the parent line is maybe it's it is this, let's print this. We're using the tree line anyway. No, no. Okay, let's print the parent line. Okay, it's going to this again. I think the head content should be the hash from, okay, it's tr. I go to zigit, the head 5fc, the parent is this, right? Here it's 1d4a, that is great. Okay, I think it says the parent line is, I think we should do this. Okay, dot next. Um, we just go to the next one and then the next one. Yeah, parent f7 e0, 5fc we go to, yeah. We're showing the parent 7 e0, and then we split this by we are doing pr.next. We not need to do that. Yeah, we go to f7. But why is it going to the, okay, I think it's not the hash, but let's see what is in the pr.rest. It might be some, I think the other files as well. Yeah, it's not the rest, but it's just the next one. Is parent. Okay, and then we again go to the parent, but this time there is no parent, so that's the end of the file. So what if we print this? We get the parent. Wait, the head content. We get this, right? We have this. I think we are getting it. Let's try again. Yeah, it works. So if it's a directory, we're not able to do anything. Actually, even if we get any error, I think it's 13. So when we read the file, any kind of error will just break. So we need to check what is going into this read file. reading this path. Yeah, we read save, we read this. Again, we are going to F7. Wait, we're reading the head. We're going to 5FC. We're going to F7. Now what? Yeah, there is no if you have to add a check, I think. Mem dot equal path is return. I think it's a const, but okay. We're getting an east directory. Okay, I think the path is fine, but this is an directory. Do I know if it's a directory? Status and C directory. Yeah, so we just need to see. The path here is going to be this. If it dot do we do here? How do I check if parent line dot check if iterator is null? I think I need save to put. Check if optional is null. I think the question mark is an optional. Okay, we can do this. If it dot next. So here we are going to guess parent line. We don't do this, but we do this. It's going infinite, but okay, I guess else we need to break out of this. Yeah, it works. Now if I do another commit, if I do a status here, so let's stage utils. So now if I go here to the index, it says 5FC and the tree is 1D4A. This is true. I have not committed it, so it's all in the index. If I commit this, just commit 3. Now if I see the index will be empty. Yeah, index is empty. Head is at A7, which points to tree 4A. You can actually do git log to see this. This is the latest commit. So this points to tree 4a. So this commit hash is 5fc. It's like that, right? So 4a8. Again, this is the index of the tree. Which, I mean, these are the files which were changed or modified, or added or modified or deleted. In this case, just added because you haven't written the functionality for modified. I guess we can check uh, modified as well, but will that? I think, yeah, commit, when you commit, everything is the same. Like if there's even a small change, that's going to be gone. So yeah, this is great. Like we have all the commits, and we can actually go to that commit and to see, like, if I take this commit, right? If I take this tree 4a and I want the structure to be like this, exactly like this, then what do I have to do? That is it. So that is another command, I guess. Git as a reset. We could have branches. I mean, we would have branches like in the index, not in the index, in the head, I guess. The git slash head. Instead of the commit, we can actually put our branch name, and then in the git slash refs, we can have that branch pointing to this commit. So then we can make ourselves use whichever branch we want. We do that. I mean, that's again, I think it'll take much longer than I expect. That's the problem. So if I see here in the, so I think we need to do that when adding. Do we do any head here? No? It's only in commit. When committing, we have this head path. Mm, we have this head. So we need to make this point to a default branch, which is main. So again, and we need to create the refs in the branch and the point that to the commit. And then when we are doing the log, right? Instead of just getting the file, we have to check the branch and then get the file. So we can do that. So the head path is this, and we open the file. Does file is not found? That's fine. If it exists, we get the parent rehash by directly reading this. But instead of that, we need so let's do this fetch head path. F dot write all ref slash. How does this do? It's heads dot main. So here I'm going to have head main, and I also will make path. I do that. Dot git slash refs slash heads. Slash main. Now, so we have to try it. So we have created this one, and we need to I think it's fine. We have this, and to this path we're going to write. Um, we're going to write it to refs. I mean this. How do we know that this is this? Because we have a default branch, and to that we are writing to the fetch head path. Not writing it to the fetch head path, but we are writing it to this. Just writing it to this. I don't know if this works, but so if we write it to this, then again, just thinking what can happen in log, right? In log.zip, we go for the head file and we actually make this const head ref content, and we do this head content. When we try to read the file again, this time it's going to be the head ref content and allocate it. So now we can just go and delete the index. Just delete this as well. So now if I log this, we write all. Yeah, so we need to see the status first, not staged. I will add make file and I see the status, it exists. Now I commit saying test commit 1. Yeah, we might get this. I know, like, this is a directory. Wait, did it create? Yeah, we don't want a directory. Add the make file, commit this. Yeah, head contains this. Now if I do git log, file is not found. Which file is this? Yeah, I have to read from, like, similar to how I did this in commit. Okay, just really do that. I did it here, but it's in 15. Before that, it's going from 32 to this. So it's saying it's a file not found. Head ref content. I think we have to add it with zgit, right? Don't know if this works. It isn't. But fine, because what we have in the head is this. We need to add .zgit slash to the end. We can try this. I need to append. This might be a long stream, like it's around 6 hours now. This is probably one of the longest. So I think we're very near to the end to move this from just a commit to the head. We just have to handle the logs because everything else is working fine. Maybe so the problem now is that it's saying file not found because yeah, we need to append something, append comp time string to this. um Use a comp time. This don't work, won't work. I just want to append two strings. So we might do this like, I think it's in status, right? Yeah, create a buffer and then do that. We don't know the size of the buffer. So it's cgate slash refs slash heads slash. So I think it's dot cgate slash. Here it's head ref content. Actually we have to try read file. This is a path. We need an allocator, right? Wait, we need an allocator. Yeah. How does this even work? I'm not sure. Doesn't. Because okay, let's say this is something like maximum 1000. It's not gonna be more than that. We get it now. So if I commit to yeah, so the parent is going to be from here. You have to change that in commit because where we're writing the parent, wherever we are writing it, just writing the parent rehash fetch head path. Yeah, we don't want to do that directly. We want to do it like this. We want to do it like this. Head content. We want to do replace this. So head ref content. I think head content, right? Let's say head buffer. So the head content is the actual content of the head, which we want to be using here. Read that here. Parent shouldn't be like that. We have to delete this and retry. 21 doesn't exist. This is from 38. Okay, because I want to create that, right? We are reading it directly. Okay. We have to actually check if this exists. Maybe we can do that here. I do. So let's add src/utils. Commit it as to log. It works. This is great, right? So now even we are not using the direct head, but we are doing in a similar way that um, what do you say? Git does. But now we can even have multiple branches because the head points to main branch here. Maybe it can point to some other branch here, and then when we can have some command to create a branch which creates another head, and this main is pointing to this tree D92, and our new branch can point to some other commit because it's different from whatever the main branch is. And yeah, so I think this is what I wanted to do. So this is not the complete functional way, but the commit, logs, status, these are the daily ones people use, commit being the most important one. And actually wanted to write that, and it's quite tricky to write, but I think still we can do better in terms of more functionality being added. And yeah, that's it for this video. It's a long one, but thank you guys for watching. Bye.